Okay, so in this video we're going to look at the formal derivation of the first trig formula that you have to derive for the leaving cert. So the first one that you have to prove here is that cos squared a, plus sine squared a is equal to 1. With a lot of my videos here, you're going to notice that I introduce a green box. So in the green box here, I've called it the need to remember. Okay. If you can remember this green box and then trust your maths ability, you're probably going to find your way through the proof as opposed to trying to learn something off by heart. So what you need to remember is to draw the unit circle, and then you're going to use the distance formula between the center and the point. So first of all, we're drawing the unit circle. So we consider the x-axis here to be the cos axis, and the y-axis here to be the sine axis. We draw an angle in. Now, I've drawn in 45 degrees just to show you what this actually means. The next diagram won't have 45 degrees drawn in. So the cos of 45 degrees, well, what actually is it? The cos of 45 degrees is where your line drawn from the cos or the x-axis at 45 degrees hits the unit circle. And it's important to note that it's a unit circle, its radius is 1. So cos is the x coordinate in pink here. This point right here is cos of 45 degrees. And this point over here is the sine of 45 degrees. So if you're thinking of them as cos as x, sine as y, and we've gotten 2 points out of it. So we can describe this point as the point cos 45, sine 45. But we're not dealing with an angle of 45 degrees. We're dealing with angles capital A or A. So the yellow box here is required for the actual proof. Draw your unit circle, radius 1, 1. It's going to come to -1 and -1 on the x and y axis. You're going to draw in an angle A. So that means this point is cos A, sine A, because if we come down, this point right here is cos A. So the x coordinate is cos A and the y coordinate is sine A. So that's the first step of the green box. Draw your unit circle. The second step is to use the distance formula between the center and the point. So looking at the distance formula then, so how can we calculate the distance? We can use the distance formula between 0, 0, which is our x1, y1, and our x2, y2, which is cos A, sine A. We have our distance formula here from coordinate geometry. But do I actually know the distance? Do I know the distance between these 2 points? Yes, it's 1. So even when I'm going to use the distance formula here, I know it should equals to 1. So, talking you through the last step of it. Filling in what we knew our x1, y1 was. So, x1 was 0, x2 was cos A, y2 was sine A, y1 was 0. Cos A minus 0 is cos A. Sine A minus 0 is sine A. Square both sides. So I've gotten rid of this square root by squaring both sides. So 1 squared ends up just being 1. Cos squared A, sine squared A. And we always simplify it and write it in this manner, where the square is on the cos, not on the A. And the sine is on the square is on the sine and not on the A. So important note over here, but not needed. So just to explain the difference, or how I've actually gone from here down to here. Cos squared A is equal to cos A all squared, but not equal to cos A squared. Here, it is just the angle that is being squared, where here it is the entire cos A. So be very, very careful where you are putting the square. The square does not go here and here. It has to go where it is written in black there. And that is the proof.